All right, sorry to interrupt, but it's 1 o'clock, so to stay on schedule, I'm going to get going. So, the next speaker is me, Chuck Brandel with ISG. Be talking about storage and BMP projects and some cost updates from the last year and a half. Gave a similar presentation last year in Wilmer about a year and a half ago. So I have some of those projects that I'll cover again, and we have some new ones. If I can get there we go. So I think you guys have heard about ISG today. We have 8 offices throughout 4 states. We actually designed this building and this addition. It's a great space. If you haven't, they have some pretty good concerts here. It's very good sound. And then being right across the street, we get to use the space. So my agenda, importance of drainage, repairs and improvements, storage that maximizes water quality benefits, proven results, and then I'm going to talk a little bit about how some systems handled our recent rains in the area and some of the future projects. So first off, importance of drainage. Most of us here, southern Minnesota, northern Iowa, we need artificial drainage to support agriculture. Without it, we have shallow lakes, wetlands. The picture on the screen was a drainage system that was that failed 2 years ago. Then they got 30 extra inches of rain and no outlet. They had 500-600 acres underwater. So the Minnesota Drainage Statutes, I won't go over a lot of this because some of this was covered earlier, really developed 1800s, refined 1900s, and most of the public systems that were put in about 100 years ago, between 1900 and 1920. I don't have the exact number, but there's approximately 10,000 public drainage systems in Minnesota, so we have a lot of infrastructure that is old or failing or needing upgrades. So a little bit on repairs and improvements. Why are we looking at repairs and improvements? That's because we have deteriorating systems. You see the picture of the pipe collapsing, ditch sloughing in, either due to lack of maintenance, too much rain, and we're looking at improvements to replace this failing infrastructure, adding depth, capacity, and then today's tilings, the system tilings or private tiling systems are a lot different than what they were 100 years ago when these systems were designed. So more pictures of just deteriorating systems. This infrastructure that was put in 100 years ago has way outlasted its life. Most engineers, if you look at the Federal Highway Association and other experts in the country, will say a concrete pipe, the maximum life on a concrete pipe is 100 years. Most of these systems were at 100 years or more. Repairs, we look at it a little bit different between ditches and tile, but really we have to go back, determine the legal grade, look at the bridges and culverts and everything that's been constructed within the system. But really the repair is about the same size, same slope. The drainage statute allows us to replace a system with the nearest size available at the same slope, same width, really the same capacity. But with a lot of the systems that were put in 100 years ago, we don't have depth, or we've had subsidence of lighter soils, and we need to look at doing something different. For improvements, usually we're looking at either depth, capacity, or realignments. Couple rules that we have, we can utilize today's technology to get the best drainage for the lowest price. Compared to 100 years ago or even 70 years ago, we have better pipe. It's easier to excavate. We can gain 2 feet of depth easier than they could have with a shovel or a bull or horses and manpower. So we compare the repair costs to the improvement costs, and usually, on average, for about 20–25% more, you can get 5 times the drainage on a drainage improvement. Drainage coefficients for a lot of tile systems in southern Minnesota are anywhere from 0.1 to 0.25 of an inch. Today's standard that we use at least is a ½ inch drainage coefficient. Through improvements, we meet with landowners, have informational meetings, do a feasibility study, develop options, and then after that, after we get some consensus from the landowners, we meet with agencies, talk about how we're affecting natural waterways or outlets. ISG standards for an improvement, we look at no net increase in peak flow if we don't have an adequate outlet. That means we have to do some sort of storage or treatment. We do not try not to change natural water courses. Obviously, we have a buffer law, install buffers, and then identify BMPs at wetland enhancement areas. Really what we call a multi-purpose drainage management plan. Identify all the areas in a watershed where you could do storage or do treatment, but at the same time looking at that we've got to increase production. So for improvements, for tile improvements, like I said, we use a ½ inch drainage coefficient, add intakes at road crossings, really make sure everything's connected, and a few other rules that we follow. Ditches, we usually look at a 1 inch drainage coefficient. We're doing a few improvements where we're lowering grass waterways and turning those into open ditches. But then also using bridges and culverts as restrictions or flow restrictions, similar to what Henry talked about in the altered hydrology presentation earlier. Really, with improvements, it's a balance. Drainage and I'm not quoting it exactly, but in general, drainage statute says if you do an improvement, you need to show that there's benefits. Well, if you're showing that there's benefits, usually that means you're increasing production. Well, to increase in production, you're getting more capacity. Well, it also says in the drainage statute that your outlet has to be adequate. So you need to look at downstream effects. If your outlet's not adequate and you're increasing capacity, well, then you need to offset that somehow. So usually we look at storage. And then we put together multi-drainage management plans. That is a requirement that you look at alternative practices under the drainage statute. Thus, you need water quality, or need to look at water quality. If you're doing some sort of storage or treatment, you're doing water quality. But then you also have to be cost effective under the drainage statute. Your benefits can't outweigh your cost, so you have to be creative, you have to look for opportunities, and in some cases you need outside funding. So, there's an outlet of a 42-inch pipe outlet on the right and a pond holding water on the left. So we look to storage when we do large improvements. So storage, the benefits of storage. It reduces peak flow, provides a water quality benefit. You look at the graph that's on the screen, and I don't think my pointer's gonna quite do it, but you take the peak off of the hydrograph. So if you're going to increase flow, you figure out how much storage you need to either get it at or below what the existing flow rate or capacity was, or in some cases you go above and beyond if you can get outside funding or you have an outlet that is really not adequate. So, other benefits of storage can reduce outlet velocity, can provide wildlife habitat, sediment trap, and other benefits. So let's see if I can get this video to play. So I have a few project examples. First one is Martin County Ditch 29. Total project just for the pond itself was $500,000. The rest of the project was another $3 million. They had a 0.10 drainage coefficient for their outlet, so we needed a large amount of storage. So we did a 2-celled pond. The northern cell, which was a smaller cell, was actually already in a wetland program. Excuse me. And we worked with Bowser and other agencies to essentially add to that easement. So the area on the top of the screen was already in a wetland easement. So we dug that area approximately 2 feet deeper. And the area south of that, we created essentially a surge pond, and it's 6 feet deep. I'm starting to lose my voice, sorry. We have a 60-inch pipe coming in and a 36-inch pipe coming out. So this picture was taken last Friday. I don't know the exact rain amounts that they've had south of Fairmont, but my guess is it's at least over 6 inches in the last week. This next project is Blue Earth County Ditch 96 and a Cobb River overflow. Controversial project where we added a 2-foot weir to the end of an open ditch. Ditch 96 and 95 actually act as an overflow for the Cobb River to the Maple River. There was a berm along the Cobb River that had been established right around 1980. And fortunately, they put the elevation of the berm on the ditch plans. Landowners then asked, we need to put that berm back because it had blown out some years past. And there was a lot of water running through the ditch system. They wanted to build an 8 to 10 foot tall berm and weir. We told them that the berm height was originally only 2 feet tall. So that's all we could put back. The people on the backside of Riverside said, we don't want any berm at all. We like our water going through, we like our overflow the way it is. We had a meeting out on site. I stuck the tape in the ground and said the weir's going to be this high. There's still some controversy about it, but we worked with the landowner right next to the river. He went into a RIM WRP easement, and thus we were able to add 80 acre feet and move the berm away from the river closer to the road, adding a little bit more storage into the system. Oh, no, I did it. Shouldn't have paused it. Now you guys get to watch it again. I don't think there's a way for me to fast forward. Like I said, here's the 2-celled of the pond. This was taken last August, right after construction was completed, and this flooding picture was taken last Friday. That 60-inch pipe. If you want to go to the virtual reality area, you can see the 60-inch pipe kind of burping itself, bubbling up as it's outletting or into the pond. One other thing to note, the rest of the watershed didn't have very much flooding because of the drainage improvement. We're trying to balance peak flows downstream. So we're looking at what was the existing peak flow, what does the improvement do to change that, and how can we balance that back, or is there something else downstream that we can slow down flow really and temporarily hold it in one spot. We're making the wettest land a little wetter, but making the other land more productive. Excuse me. Jackson JD 30 project in the Heron Lake Watershed. About $137,000 pond, created 14 acre feet of storage in an existing pasture area. The improvement included deepening a waterway into an open ditch and upsizing tile that had capacity of about 0.1 to 0.2 to a half-inch drainage coefficient. You can see the lake in the background. Le Sueur Blue Earth JD2. This was a privately funded wetland bank. So another option for storage is creating wetlands. Instead of the surge pond that maybe bumps up 6 to 8 feet, we created a 90-acre wetland bank. This was funded, a company that does wetlands and wetland banks bought the property. They like to use it for hunting, and they also like to gain some of the dollar value from the wetland bank. They had talked to a local mining company that needed wetland credits, and they worked together to construct this wetland bank. For the, it is the outlet of the Sueur Blue Earth JD2. On the ditch system itself, it had a built-in about 5-foot drop just outside of the area for this wetland. So we were able to build a large sheet pile weir. We backed up water to just below that 5-foot drop and created the large basin. It's doing very well. This footage is from last year. Nicollet County CD 62. This is construction footage. You probably saw some of this during lunch where I'm moving some of the dirt. Just under 5-acre pond, another large improvement. The biggest issue on this improvement is they had portions of the ditch where the tile was almost coming out of the ground, but they also wanted to increase capacity. So we put the pond in and shared it with 3 landowners. You can kind of see where property lines are here. That wasn't necessarily the lowest spot, but it was a compromise that all 3 landowners lost a little bit of land. There were lower spots just to the south or to the east. So this picture was taken this spring before we got all of the rain, probably about a month ago. Blue Earth JD 34. This project is just northeast of Mankato. Another improvement project. The outlet of the system was a 24-inch pipe. It was collapsing. There was also a solar farm that was going up in the watershed that wanted to do some realignment. So we worked in conjunction with the solar farm and the landowners and did improved essentially the entire watershed. Put a 2.5-acre pond at the outlet. You can see the solar farm here. Increased the size of the tile from a 24-inch to a 36-inch. Put in the pond, added just under 17 acre-feet of storage. The pond has a 24-inch outlet, and it drains almost directly into the Eagle Lake. Another project, this is last year, Martin JD20. The project's still under construction. Relatively small pond, 6 acres, or 6 acre-feet, 1 acre in size. Similar improvement to JD34, where we had a 24-inch outlet and went to a 36-inch outlet. The reason we could go with a smaller pond and less storage in this area is that there were some CREP and RIM WRP easements in the watershed, and we did some enhancements and modifications to those to increase storage there also. So no cost to the landowners on the wetland areas except for some structures and modification of the tile system. All right. Now that I've got you dizzy, that's enough for videos. There's a lot of other projects that have occurred in the past 2 years. This example, JD13 in Wetland County, I talked about it a little bit last year. We just finalized the project about a month ago. MnDOT constructed Highway 60, was adding 2 lanes, bought some land for storage. We worked with landowners in MnDOT to enhance that storage area, make it deeper, put more controls on the outlet, and we gained 112 acre-feet of storage for both the highway and the ditch system. JD 51 in Martin County used 2 ponds in the watershed, one on the very upper end, one near the outlet, to accommodate an improvement. New project this year, just started construction, Blue Earth JD 9. Excuse me. It's pretty much an all-tile system except for the last mile is an open ditch. The open ditch was constructed right about 2001, 2002, and the rest of the system was left. We televised the system a few years ago. The tile system is shallow. It was basically completely non-functional. So we looked at kind of a multi-stage approach on this system. A portion of the open ditch is naturally forming a 2-stage ditch, so we're going to leave that and maintain that. We had an area that, because of the tile failure and shallow tile, was still trying to be farmed, but really it had been turned to grass, but not into any permanent easement. So we have designed that as a wetland restoration. And then along with that, we're doing a 2-acre pond. So we have a 36-acre total wetland restoration along with a 2-acre pond. A few other projects. JD 45 in Jackson County, about a 3,500 acre watershed with 2 outlets. So we did 2 ponds, one at each outlet. Total storage of about 40 acre feet. And, excuse me, cost about $5,000 per acre foot. Martin County CD 30, another similar design pond. This one we actually went with a 2-stage design. So the bottom stage, closest to the bottom of the screen, is a couple feet higher than the other stage. There's been discussion about sediment getting back up after larger events. So this design is to try to see if a 2-stage design might be a better design for a storage pond system. Clean out the upper basin first and have a kind of a backup basin downstream. I'll skip to, here are the numbers. So a sample of these projects, total storage of about 350 acre feet. The average cost is about $5,200 per acre foot of storage. In many of these watersheds, the storage can vary from 2% of the watershed to 5% of the watershed. Now Martin CD 29 had about 170 acre feet, and we got a lot of bang for our buck out of that. If you take that cost out of this summary, you end up with an average cost of about $7,000 per acre foot, which is a number I would use and kind of use going forward. Years past, we've talked about $3,000 to $5,000 per acre foot, but we're seeing the need for more storage, poorer outlets, and obviously increasing cost. Other storage and treatment options that we've done on repairs or improvements, CD 56, we used the side inlet calculator, put in 10 alternative side inlets, and then also did 2-stage ditch maintenance. This system drains into the Lake Crystal and through the city of Lake Crystal, very light soils. On average, this system gets a major cleaning about every 8 years because of the amount of sediment that gets into the ditch system. So we're trying to do some other things to stretch that timeline out, save dollars for the landowners. Other projects, large bioreactor in Faribault County that went in about 2 years ago, $260,000 cost for a 700 acre watershed, 5 foot deep by 25 foot wide by 135 foot long bioreactors, 3 of them staged in series. We also did a bioreactor across the river from that one, smaller in size, and a saturated buffer, about $30,000 for the bioreactor and $20,000 for the saturated buffer. One of the big new BMPs that we've done in the last year is alternative side inlets. If you went to the earlier presentation by Bailey Griffin and Dusty Anderson, Gaberba hired ISG to develop an alternative side inlet calculator, and we have been installing these things like crazy. If you weren't in that presentation, some of the goals are to provide storage along the side of an open ditch for about 24 hours. And doing side inlets a little bit differently than the past. If you see all the red dots on the map, those are areas where side inlets have been installed or are about to be installed. The gray areas are other projects that are planned that would have those. One of the advantages to the ASIs are most of these projects are not improvement projects, they're repairs. So we're adding storage to a repair even though it's not required. We're looking at multi-purpose drainage and adding that storage in. The storage amount can range depending on the size of the ditch, the size of the berm, and the watershed going to it. Using an average of 1 acre foot per storage per ASI, we're getting about 200 acre feet of storage, over 200 that have been installed since July of last year. The average cost has been anywhere from $1,000 to $6,000. If I take the average of these projects, we're at $2,500. But a range in size. Some of these side inlets are 10 inches, 12 inches, some of them are 24. So that's why you get the range in cost. Proven results. As infrastructure continues to deteriorate, we got to look at better ways to increase production at the same time looking at storage and water quality. Here's some past results from CD57. There are current and more updated results that we're actually going to be meeting on next week, but we have shown that reduction in peak flow can equal reduction in nutrients. So a little story about what's happened here in the last couple weeks. This is the rainfall map from Monday of this week to 14 days before. Anywhere in the dark red and pink, the dark red is 8 to 10 inches, or 10, and the pink areas are above 10 inches. So we've had some very significant rain. Look at the last 7 days from Monday of this week. You can still see there's a lot of dark red. Now this is just what's being calculated from radar. We've got local results that actually show higher rain events isolated. So looking at a couple projects, I talked about JD34. On June 16th, we got 3+ inches of rain in an isolated area just northeast of Mankato. And on June 19th, checked some rain gauges and other things. Landowners said that they got over 4 inches of rain overnight. So we got a pile of water very quickly. This ditch system is still under construction. So most of the, probably over 50% of the pipe that was put in this winter or spring. So we have some compacted ground over the top of the pipe. The first rain event soaked it in. The second rain event, we ended up with flooded roads and a significant amount of water. This is on June 19th when these pictures were taken right after the event. 2 days later, the system did take it. Water's going down, the road is passable. We looked at the pond. We didn't get there on June 19th. It was just too muddy to get out there. It was raining too much. We didn't send the drone out. but on June 21st we got down there. The 36-inch pipe is completely inundated still. So we saw the road flooding went down, but the pond is still bumped up. And then on June 25th, you can see the pond outlet and the pond inlet. The pond is starting to go down. So we're not monitoring these, but I have pictures to show, at least tell a little bit of the story. Jackson JD 45, landowners said they got 8 inches of rain over just over 2 days' time. This improvement just finished about a month ago. This system went from about a 0.1 drainage coefficient to a 1/2 inch drainage coefficient. We had some localized flooding. You can see intakes underwater. There's an intake very much underwater. We had a pond on the end of the system. The pond completely filled up. But by June 22nd, most of the flooding on the land was gone. Our pond is still holding water, and our outlet did not overtop. Martin, CD 29. There's the pond on June 22nd. I don't have the exact rainfall amounts here, but this pond is probably bumped up 8 feet at this point. But if you can look into the upper left-hand corner of the project, you don't see a lot of localized flooding because that's where the improvement occurred. But if we turn the camera to the south, the system drains off to the left. To the south is another drainage system. You can see all the localized flooding at that point. So what's in store? What's coming up? We have many projects. We're looking at a project in Wright County, CD 10, looking at storage, wetlands, alternative side inlets. On the screen is one of the multi-purpose drainage management plans. This system is looking at really a repair, but the system drains through lakes, so we are looking at storage and wetland options there. Jackson County JD 13 and JD 9, getting close to having that ready to go. We've got a 20,000 acre watershed that is looking at about $13 million of improvements to it. Very significant project. We have a 48-inch pipe in the watershed that is failing and is being replaced. Because of the size of the watershed and the magnitude of the improvement, we're looking at least 4 storage areas throughout the watershed. This is a picture of just the eastern portion of the watershed. The blue areas represent 2 storage areas. You can see we're fairly zoomed out. They're very large storage areas. We already have complaints downstream that the system is flooding too much, and we have complaints west of this that the system doesn't work adequately. So we're looking at it's essentially 3 large branches of the system, JD 9 and 2 branches of JD 13, putting in a pond for each one of those branches in the upper part of the watershed, and then putting ponds on the lower end of the system to stage that peak throughout the watershed. So hoping to have final hearings later this year on this project. Then an example of what happens when the multi-purpose drainage management plan works. We were doing a repair to, it used to be called JD 514, now it's CD 514 in Faribault County. It was a ditch cleaning. We were adding some side inlets, and we put together a multi-purpose drainage management plan, and there was one spot in the watershed that stuck out on the plan where we were showing that you could do a wetland enhancement or a wetland bank. After the meetings, landowners came and talked to Marissa Lohr, who's here, and said, we saw that area and we think that's a good idea. Through a lot of hard work, because there's 3 landowners involved, I think cross our fingers, we're gonna make this thing happen. But we're gonna do a 101 acre wetland restoration with the first initial contact was the landowner saw the MDM plan and said that's a good idea. So just the importance of doing those and showing what can be done in a watershed, and then getting willing landowners. A couple other projects that are upcoming. Couple to note, some of these are in litigation, so not sure if they're going to happen, but they're on the list. Potentially a 7-acre pond and 2-stage ditch in the Heron Lake Watershed on Jackson CD3. Jackson JD3, we've gotten some outside funding to do some wetlands and some erosion protection. The ditch system has an outlet into Heron Lake that is one of the most beat up ditches I've seen, large sloughs. The rest of the system wants to do an improvement, and we're like, you guys got to work together. We got to figure this thing out. We got to solve the outlet issue with storage and probably wetlands. And then a few other projects in LeSueur County, Lackaparle, and Faribault County. Going way faster than I thought. Closing remarks. Past projects are important to show that BMPs can work. Showing the pictures, showing that we can get tile improvements and storage. I think it's very important. We did the CD57 project, which finished in 2011, and I've shown multiple landowners that system, either pictures or they've gone and seen it in person, to trust us that this can work. Changes to 103E, looking at MDM plans is also key, and putting the MDM plans in front of landowners and showing that there's things that could work. Like I stated before, improvements need to balance drainage and downstream effects. We're using storage to solve that, but alternate practices like ASIs and saturated buffers can work, especially when you're looking at open ditches. Funding, and really to end on funding for water quality, is a key factor as we look at low crop prices and failing infrastructure. We can enhance some of these projects if we can get funding in place to help out. So that's what I've got. I've got probably 10 minutes for questions.
What is the targeted time frame that you'd like to see the water sit in the storage area? The compromise between effective water quality treatment and reducing the peak flow, and yet having that storage available for the next rain event?
It depends on the type of storage area. So for an alternative side inlet, we're targeting 24 hours. We could maybe target a little bit more than that, but that's because that is backing water up into the field. The larger storage areas, we're looking at multi-day. It depends on the size of the watershed and how much outlet, but we could have water for a week. And you've seen it on CD57, that water, I mean, it's in your backyard, that water can stay in that basin for quite a long time. In that case, we've got a 48-inch pipe coming in and a 15-inch pipe coming out. So that has a little more extended time than like JD34, which is probably 4 to 5 days, where CD57 might be 7. So it depends on the rain event too, but on average.
Thank you. Improvement projects in particular, of course, are heavily dependent on the assessment of the viewers in terms of the cost-benefit relationship. My question is, Does ISG get involved in looking at the economics as well, or do you pretty much take the work that the viewers have done as the definitive?
We're by statute, the viewers are supposed to come up with their assessment, but we can work with them. So we do give an opinion on here's how much increased capacity. We show the viewers that more detailed information than I have. We may look at that a flooding area changed from 4 days to a day and a half. So we give as much information as we can to show that there is a benefit. At the same time, those lands that have easements or storage, those are going to come out of production, or if we have temporary storage, showing that we could show the engineering, show the water, but make the case that we're either benefiting or damaging certain areas. So we do work with the viewers back and forth on those type of issues.
So we've heard a bit about the soil health practices, cover crop practices, and now we've heard about the engineering solutions. How do you talk about the interplay between those two kinds of solutions, I guess, to some of the same issues?
Can you just repeat that? Sorry.
Yeah, we're getting some strange feedback here.
Yeah.
The
Yep.
Chuck, why don't you talk about the interplay between the engineering solutions that you're sort of outlining here and the soil health practices, cover cropping practices that we've also heard about today that are sort of aimed at accomplishing the same ends in different ways. Talk about the interplay there.
Yeah, so if we're hired by the Drainage Authority, we have some limitations. We're hired to do work on the infrastructure. So we have easements and things like that. So that's what we target for large storage. But at the same time, when we look at our multi-purpose drainage management plans, we take the whole watershed. Say, here's where controlled drainage could go. Here's where good soil health practices could go, which really is almost anywhere. But and then go over those with landowners to say, here's a whole list of practices you can do. As the Drainage Authority's engineer, we have control over this corridor and can do things. But here are other things that you can look at. Recent conversations with one of our clients was looking at potential improvement projects. What if we modeled the entire system that it was doing cover crops or no-till, and compare that to the model with standard practices and what size pipe and what cost we would have. So that's something that we are going to be looking at a little bit closer. We've done that on a handful of projects. One that I can think of, Martin Watmon JD2. We had a presentation on controlled drainage, and we had a handful of landowners that said, we're going to put in controlled drainage. Then we looked at how that affected the sizing of the tile and the need for other storage, and talked about those costs. And we had 3 or 4 landowners interested. I know one for surely did it. So we do have that interaction. We're somewhat tied with, we could control practices on the infrastructure, but we need to show the suite of practices to landowners during the process. Hope that answers.
Chuck, I had the opportunity to watch one of your engineers get cross-examined by another modeler in regards to SWIM, XP, and I'm just thinking that as we see these greater pulses and storms, and you're there trying to balance that off with the engineering designs, how confident are you that currently that's a good balance, that your SWIM is working well to design what you need to?
We're very confident. We got a talented team of modelers and engineers that know what they're doing. We use very detailed modeling, XP SWIM For those that don't know about it, and I'm not the expert either, but it's got you take the 3D model of the entire system, and then you can model the what we call the 2D flow versus a 1D flow, pipe flow versus overland flow. So we take all those factors into play. But the one thing that I think we do a good job of is the other day that when it was raining like crazy, we told all of our engineers to get out of the office and go check out your projects. Go look at it, see how it's reacting, see where the overflows are, see where the problems are, and ground truth your model as much as possible. Spending the extra time to get the drone out there and show where flooding areas are. That's one of the best ways to both train an engineer how to model correctly, but to ground truth your models. I mean, I did it myself when I was learning 15 years ago. I had a 25-year event go through a system I was modeling the right time of year where I could go out there, the grass was tipped over, I knew what the elevations are, adjusted factors in our model. So that's one of the best ways that we could train and learn from, and then using our data that we have from CD57.
The experiment station in Lamberton has had a project going on for a few years now using impounded water for irrigation through drip tape. What potential do you see there for using such a system to increase total storage capacity, reducing total flows? And then does drainage law have anything to say on whose water it is? As far as who would have the right to use it?
Sorry, I was getting some feedback. Are you asking about irrigation out of some of these? Sub-irrigation. Yeah, we've looked at that with a few landowners and contractors. A lot of the systems that we set up, we're just constructing for that surge. So it might be like we talked about, a 5 to 7 acre, 7-day surge. Well, that's not when you need the irrigation, the sub-irrigation. So what you could do, and Martin 29 would be a good example, dig the whole thing an extra 2 or 3 feet deeper and create permanent storage. And that could be used for sub-irrigation, and you just cycle it right through. When we look at the cost-benefit ratio, we do over-dig a lot of the ponds to create a sediment storage area, but for the size of the watershed, it's relatively small. Now, whose water is it? That could be set up when we do the pond design. You could have the landowner that you're buying the easement from say, instead of $6,500 an acre, I'll take the easement for $4,000 an acre, but I get to use the water for sub-irrigation. I get to control it. As long as you're not damaging the tile system or the public system, I think there's ways that we could do that. Be creative, really. All right, I think that's it. Thank you. We're going to take about a 12-minute break, and then we'll get things set up here for the panel, and then we'll have a little discussion on tiling and wetlands.